All right, welcome back for part 2. So now that we understand interval and inequality notation, we are going to use it to determine where a function is positive, 0, or negative. Although these words may look like a lot, really and truly we are just asking ourselves, where is our graph above, below, or on the x-axis? Now is a great time as well to pause, and if you would like to color code, you can go grab 3 unique colors. I have highlighters on the bookshelf by the door, or you can use your own. So if a function is positive, that means the outputs or the y values are positive. Positive 1, 2, 3, 4, 5, and so on. Meaning that we are above the x-axis and all of our outputs are greater than 0. If a function is negative, it is the opposite. I am now below the x-axis, meaning my outputs are less than 0, or in other words, they are all of our negative numbers, negative 1, negative 2, negative 3, and so on and so forth. If a function is exactly 0, meaning it is on the x-axis, we refer to this as a 0 of the function, which you previously have encountered and called an x-intercept. An important note to make is that when we describe a function, we are describing the outputs of that graph. So for example, when I look at the positive intervals, so I want to know my graph is positive or above the x-axis, I notice it is above the x-axis right here and over here. In order to determine the intervals, we use the corresponding x values. So for example, on this interval on the left-hand side, my graph is above the x-axis so long as x is less than negative 3. Notice that at negative 3 right here, my graph is not positive. It is exactly on the x-axis. So if I were to write this out using an interval notation, I would say that the value is between negative infinity and negative 3 using a parentheses on both sides. For my other interval, I notice that so long as x is between 1 and 4, I am also above the x-axis. Again, I am excluding the values of x equals 1 and x equals 4 because at those values I am on the x-axis, not strictly above it. In AP Pre-Calculus, we are big on explaining our thinking, so you'll often be asked to provide a sentence similar to this one where you claim that a function is positive because the graph is above the x-axis. In this blank space up at the top, it might be nice to leave yourself a note that this means we have positive y or output values. Before I do the negative interval, I encourage you to try it yourself, so you might want to pause the video. Remember, for a negative interval, this means that we are looking at negative y or outputs. My graph is going to be underneath the x-axis. So if I return to my graph, that's going to be this portion right here and this portion right here. So I notice that is any x value between negative 3 and 1 and greater than 4. So any value that is between negative 3 and 1 or greater than 4. Once again, I can say that my function is negative because the graph is below the x-axis. The very last thing we'll discuss is our zeros or our horizontal intercepts, which once again is a fancy word for x-intercepts. This is when our y value equals 0. These are going to be points on our x-axis. So if I look at my graph, I am on the x-axis at negative 3, positive 1, and positive 4. And I'm going to represent these as points. -3, comma 0, +1, comma 0, and +4, comma 0. The very final thing we're going to discuss is our y-intercept, which is also called the vertical intercept. This is when x equals 0, and it is on our y-axis. This will always be a singular point, which in this case is 0, comma, -3. That's it for this assignment. At this point, you need to make sure that you have both your section 1.1 and your section 1.2 homework. Please use the remaining class period to get started on those assignments. And remember that I have study group tomorrow and Friday during lunch. I'm also available 2nd, 7th, and 4th period, and the math lab is also open 3rd, 5th, and 6th. I will see you in class on Friday, if not sooner.